Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 10, Probability of Composite Events. And in this video, we're going to be taking a look at mutually exclusive events. So this is basically finding the probability of an either-or. Okay, and what I mean by that is, what is the probability of this happening or that happening? So they're mutually exclusive. They're two events that cannot happen at the same time. But you want to know what is the probability of one or the other coming to fruition. So for example, if you're rolling two die, okay, they might want to know what is the probability of rolling a 5 or an even number. What is the probability of rolling a sum of 5? So you're rolling two die. So I've got two six-sided number cubes, and I roll them, and I want to know what is the probability of getting a sum of 5 and an even number. Or an even number, not and. So either a sum of 5 or an even number. And so really the key here is when you have mutually exclusive events, when you have that or in there. Okay? At that point, you are looking to add. You're going to find what is the probability of getting a sum of 5, and you're going to add it to the probability of getting a sum that is even. Okay? These are mutually exclusive events. I cannot get both an even number and a sum of 5. Okay? The sum cannot be both even and 5. Okay? Because if the sum is 5, then it's not even. So these are mutually exclusive events. So you're going to find the probability of each and then add them up. Okay? So to find the probability of for the two die to have a sum of 5, you're basically going to have to make a chart a lot of times. And some people can possibly do it in their head, but in situations like this, you really want to make a chart because it guarantees your accuracy. I'm going to show you what it looks like. Okay, so we have 1, 2, 3, 4, 5, and 6. Okay, and we have 1, 2, 3, 4, 5, and 6. So basically, just like with all of the other probability stuff we've been doing, the two fractions you're going to have the whole on bottom. The whole is going to represent what is the total number of possible outcomes. What are the total number of possible sums I could get? Well, the total possible outcomes is going to be 36 because one die has 6 numbers and the other die has 6 numbers. So there's a total outcome of 36 different pairs of numbers that could be rolled, and so there's a total possible outcome of 36 sums because each pair of numbers is being added to get one sum. So since there are 36 pairs, those 36 pairs are going to be added to get you 36 sums. So this is just like all the other videos. I have 6 possible outcomes for die 1, 6 possible outcomes for die 2, and so if you want to find the total possible outcomes of both die together, you would multiply them and you would get your 36 total possible sums. Now, out of those 36 sums, how many of those sums are going to get me a number that's 5? And how many of those sums are going to get me a number that's even? Well, the even one should be pretty simple. Every other number is even, so obviously, since there's an even number of sums, half of the sums have to be even. Okay? If you have 4 numbers, you have 1, 2, 3, and 4, half of those numbers are even because 2 and 4 are even. So as long as you have an even number of sums, you have an even number of even sums, if you can kind of catch what I'm saying there. If you have sums that total out to be 2, 3, 4, 5, 6, 7, 8, and 9, okay, we have 1, 2, 3, 4, 5, 6, 7, 8 sums here. Okay, We have 2, 3, 4, 5, 6, 7, 8, 9. 8 total sums there, and because the number of sums is even, there's 8 sums, 4 of them must be even numbers. 2, 4, 6, and 8. Same concept applies over here. I have 36 total sums, so 18 of them must be even sums. Just because of the way evens and odds work. Every other number is even. So that one's pretty simple. The harder one is figuring out how many of those sums equal exactly 5. So that's where the chart comes in handy. You fill out the chart. You're going to start to notice a pattern. So what I'm doing here is I'm kind of bolding this line just to separate this vertical column and this horizontal column, because these numbers do not count. All the numbers inside this square represent all the possible 36 sums. And what you're going to notice is all of your 5s end up right there, and there's a total of 4 5s. And so you'll end up with 22 out of 36 possible favorable outcomes. That is your probability. Yes, that can be reduced to 11/18. So if there are any questions on mutually exclusive events, please let me know. But I mean, I think it's pretty self-explanatory why this works. We're looking for the total probability of mutually exclusive events. So either this or this. So it makes sense that you would add their probabilities together. There's a 4 in 36 chance this would happen, 18 in 36 chance this would happen, so there's a 22 in 36 chance that one of the two would happen. Because there's a total of 22 favorable outcomes for the two opportunities. So the next video is going to be on Chapter 13, Section 1. We'll be getting into polynomials.